Hello students. So as per your request, once again I will repeat this topic, electric motor. Okay. So electric motor is a device which converts electrical energy into mechanical energy. We know this one, and we use the electrical motor in electric fan, refrigerators, mixture grinder, washing machine. In this electrical devices we have electric motor where the electrical energy, because switchboard is there, from switch board we electric current provided to the that machine, and that electrical energy converted to mechanical energy. That's why the fan rotates, refrigerator, that fridge, mixture grinder, if anything it will be there, it will grind, and washing machine, you know these things. So before we discuss the working principle of electric motor, first we have an idea about the law which we used here, that because we need the force, and which law we used here, and how we can know that in which direction force will be applied, that things we get from Fleming's left hand rule. You know that the Fleming's left hand rule, if in your left hand, if thumb, forefinger and the middle finger are mutually perpendicular to each other, you stretch that these three fingers in such a way that these three fingers are mutually perpendicular to each other. Then if forefinger gives represent the magnetic field, the middle finger represent the current, then thumb will represent the direction of force. This is the Fleming's left hand rule. This is the Fleming's left hand rule. Okay. This is the forefinger. This is represent the direction of magnetic field. This is the middle finger. This gives us the direction of current. So the thumb will gives us the direction of force. So now this concept we used here in the working principle of electric motor. So this is the construction of the electric motor. In an electric motor we use two strong magnets, two different pole of two strong magnets. One is a north pole, another one is a south pole. Second, one ABCD, that is a rectangular armature, rectangular coil. It is called armature. It is wrapped by a copper coil through which electricity passes, and due to the magnetic field it experiences a force and rotates. Because this we know that if any conductor placed inside the magnetic field, it will experience a force and it will move. So if we, because this is a conductor ABCD, this is armature wrapped by the copper coil and through which the electricity also be passes, and it is placed inside the magnetic field, so it experiences a force, and due to this force this coil will rotate inside the magnetic field. The two ends of the armature will connect in two split rings. Split rings means it is not a full ring. If we cut one full ring, then whatever the two parts of a sphere, that is called a split ring. P and Q, these two are the split rings. The function of split ring, it will reverse the direction of the current flowing through the coil after every half rotation of the coil. That means whenever it will rotate, that now in this position AB will be in left side and CD arm in right side. So after half rotation, the CD comes in a left side and AB arms will comes in a right side. So due to this, that P and Q also exchange their positions, and through this whatever the direction of current in a first position, after half rotation the current direction also be reversed. Because in here, in first diagram here, you see that through AB arm the current will flows A to B direction, but after half rotation you see that in AB arm the current will flow B to A, so it will reverse due to this split ring. So this is a function of split rings, to reverse the direction of the current flowing through the coil after every half rotation of the coil, and due to after again it will be rotated, then it will come again in the same position. Now another two parts, that is X and Y. This X and Y is the carbon brasses which is to make the contact with the rotating rings. These two are not displaced from its own position when the coil will be rotate. This will make the connection between the wire and the armature, because this X and Y is connected with through a wire to the battery. X is connected, suppose positive, and Y is connected to the negative. So whenever it will move, the P and Q will be moved. After half rotation, the Q, split ring Q will contact with a X, and P will contact with a Y, like this figure. But X and Y remains fixed in their own places. These two are not displaced from their places. But the P and Q, these two are attached with a coil. So because coil is rotate, that's why P and Q, the split rings also be rotates. So the functions of split rings to reverse the direction of the current after flowing through the coil after every half rotation. Brushes is to make the contact with the rotating ring. Through them the supply current to the coil. And the armature is a rectangular iron core wrapped by a copper coil through which electricity passes. Due to the magnetic field, it will experience a force and rotates. So this is the construction of electric motor. Now we comes to the working principle of electric motor. Now here you see that the armature ABCD is placed inside a strong magnetic field. In magnetic field directed N to S. Okay. And the current will supply from the battery through brushes, then through split ring, then the armature. Then A to B, B to C, C to D, then D to Q, then Y, then towards the battery negative. This is a closed path. This is a closed path of the current. Okay. Now, in the first term, this is AB arm. If we apply the Fleming's left hand rule, so in Fleming's left hand rule, forefinger represent the magnetic field direction. So magnetic field direction N to S, this side. Okay. This one is gives us the, this middle finger gives us the direction of current, upward direction A to B. So if we stretch, this is this forefinger is N to S, direction of magnetic field. The middle finger, direction of current A to B. So if we stretch these three fingers, the thumb will represent the direction of force and it will direct it upward direction. That's why it will move in a upward direction. Upward. So if this is a coil ABCD, this side is AB, so AB moves like this way. AB side is moved like this way. Okay. Or if you see these things, wait. Suppose this side is ABCD. So after after the Fleming's law, due to the from Fleming's left hand rule, so AB side will move upward direction. Like this way. This side is CD, this side is AB. So AB, this is a normal position. After acting the force, AB move like this way. Okay. Now if we apply the Fleming's left hand rule in CD arm, you see that the current direction is this side and the magnetic field this side. So like this way. Okay. Okay. So now here thumb represent inward direction. Inward direction means, so like this way again, A, B, C, D. Okay. A, B, C, D. So CD move downward direction. If AB move upward, then it's normally CD moves downward. But still, if we apply the Fleming's left hand rule in both arm, you see that AB move upward direction, CD move downward direction, like this way. It is half rotation. Then after half rotation, AB side is come this side, CD is this side. That means this one. So P split ring come contact with Y and Q split ring come and contact with X. After again, if we apply the Fleming's law, Fleming's left hand rule, so this CD, now you see that the CD arm, the current direction will be reversed, because in first position the CD, the current direction in downward direction, but here it will be upward direction, so it will reverse. So if we apply the Fleming's left hand rule here also, we see that, you see, this is, so the force direction upward. So again this side now is CD move upward direction and AB moves downward direction, and then it come its original position. Okay, that means this is a first, this is a after half rotation second, then again it will rotate the half, again it will rotate, then it will again come in the first position. Okay, this is the working principle of electric motor. And application: electric fans, refrigerator, mixture, washing machine, everywhere we can use the electric motor. Okay, so still if you have any problem, please mention in a group. Thank you very much.